Why does it?
It's because like within the little box is the screen, and then within that it sees another. Yeah, it's a bit wonky to explain. So, right. So today we'll be covering ggplot2, which is a plotting package on top of R itself, which is kind of based on this idea known as the grammar of graphics, and that's what the GG and ggplot stands for. And what it essentially is one could say an implementation of some of those principles that were put forth however many years ago by whoever wrote that book, whose name is completely escaping me right now. But what I really like about ggplot is it's this idea where you can express what you want to plot at what in computer programming language you might consider a high level. And what that means is we're not thinking too much about translating what we want into computer speak. It's more us saying, I want this on the x-axis, I want this on the y-axis, and I want this to be a scatter plot, as opposed to writing lots of like really wonky looking code and kind of thinking more in a computer sense than a human sense, if that makes sense at all. The other really nice thing about ggplot is it interfaces really nicely with dplyr, which we learned about at our last lesson. So again, I mentioned this earlier, but I'll say it once more for people who are just joining us. We'll be touching on dplyr just to make a few things easier. If you didn't attend the last workshop, weren't able to look at the material, that's fine. I'll try to explain kind of the dplyr dabbling as we go along, but it's not really the focus of today's lesson. So don't worry if it doesn't fully make sense yet. You could have a look at it later, or you could talk to myself or James, and we could kind of iron that out. So to begin with, the first thing we're going to do is, well, first thing I'm going to do is hide this little notification thing. No. Okay, we're back. The first thing we're going to do is have RStudio open. And what we're going to do is head over to File, head to New File, and open what's known as an R notebook. So those who were there for our last lesson might find this a bit familiar. If not, the R notebook is, unlike your traditional R scripts, it's kind of a plain text file. Anything you write in it is just plain text like it would be anywhere else in Notepad and such. The cool thing about it is within an R notebook, we can specifically delineate where we want actual code to be placed and just run it just in that section, in a sense. So what I'm going to do is minimize this pane here so it's a bit easier for all of us to see. There's a bunch of text over here. Feel free to get rid of everything besides this kind of header section up here. So I will do just that. Up here, you can give this a nice little title, whatever you'd like to call it. I'll call this Intro to ggplot2. And for those who weren't with us last time, the other cool thing about the R notebook is it supports markdown headers, which is a way of formatting kind of what we're writing in the notebook. And I won't go too in-depth about it into it right now, but perhaps it'll just become more clear as we go along. So the first thing we're going to want to do with ggplot, as with all packages in R, is import it. So first in here, I'm going to add a quick markdown header. Actually, let's just import the packages as is. So in the R notebook, you can't just write code as is. If I write something in here, like this is some text, it's simply text. It's not code. So what you have to do is actually click on this insert button up here, and then click on R in the dropdown. And this will create this little, what's called a code chunk for you to actually write code in. Since clicking up and down is a bit annoying, the shortcut for that is Control-Alt-I. I will write that up here. Control-Alt-I. I know this might feel like a bit more overhead to like do the whole notebook thing instead of just writing in a script, but what it means is that you can take notes as you go along in this workshop alongside your actual code. So Control-Alt-I adds a code chunk. The first thing I'm going to do, like I mentioned, is import our packages. For that, we use the library function. So library ggplot2 is going to be our first package. And then library dplyr is going to be our second. I'm also going to get rid of all the stuff I wrote over here. Once you do that, we can run this with Control-Enter. I'll just write that down here as well. I'd say it's worthwhile to get familiar with these shortcuts because then you can work a lot faster. Current line of code. So this might raise errors. If it does, not the end of the world. If you see kind of this red text I have here, that's fine. That means this was imported just fine. This is just dplyr telling you about some package name conflicts. Nothing we have to be worried about today. If you do see other errors, feel free to flag down James, who can help you out one-on-one. But it seems most people here are doing just fine, which is awesome. So what we're going to be doing today, or covering today rather, are quick examples through some kind of common plot types. We'll be going through scatter plots, line plots, histograms, bar plots, and box plots. So hopefully like enough of a bit of a menagerie to cover the kinds of plots you'll be encountering most of the time. We won't be doing funky 4D, I don't know, matrix plots, but honestly, that's something that's a Google search or two away, because ggplot is very nicely extensible once you actually understand its basic syntax. And then after that, James will take over and get into appearance and some more fancy kind of faceting things. So the data set we'll be working with today is known as the diamonds data set. This is a pretty large data set, and I'll just introduce it over here. So if you've imported ggplot, the diamonds data set is actually already loaded into R. So you don't have to worry about downloading it or importing it or whatnot. It's basically there. So if you just type in diamonds and run this as a complete line of code with Control Enter, it'll show up down here in your notebook in this nicely formatted kind of format. And what the diamonds data set is it's a large table. It's about 54,000 observations containing statistics for various diamonds. So that includes carat, how good the cut was, the color, a certain sort of clarity designation, alongside a couple other metrics. So there's a little arrow over here you can click on and kind of scroll through it. So it's a pretty large data set, and the reason I picked this one is that it's kind of amenable to all sorts of different plots, as opposed to a smaller, more concise data set that you might just want to plot one way. That being said, if you have a bit of an older computer and you feel a bit concerned about repeatedly plotting 54,000 points, which is a completely fair thing to be worried about, you can create a smaller subset of the diamonds dataset and just work with that. So I'm just going to quickly show you how to do that before we get into plotting. So if you want to create a smaller version of this, we'll just call it D. You would create a new object D. So we would write D, the assignment operator, and then use the head function. So if you remember, the head function would give us the first 6 rows of any given data set. But the nice thing about head is that, so first I'll write diamonds, but as a second argument, we could give it a number of rows that we want. So not just, so 6 being the default, we could actually ask for about 1,000 instead.
Diamonds isn't coming up.
Yeah, okay, good.
Oh, no. And you ran the library ggplot2 function.
Yep. Yeah. Oh, no problem.
What happens if you type in ggplot2 : and then diamonds?
I didn't get it coming up either. I like re-library ggplot and then did the D head diamonds and it came up fine.
Yeah.
The head diamonds and it came up okay?
So try what I'm doing in the console right now first, though, because if you start typing in diamonds here and it shows up in the dropdown, that means it's been loaded in. So let me just make
It
this.
works fine if you do the ggplot2 : diamonds.
So that
I
means
haven't loaded ggplot.
try loading in ggplot2 again. What I'm going to show you here is probably pretty redundant, but you could just do diamonds, assignment operator, ggplot2 : diamonds. This is the sort of syntax we usually use when we're not importing a package, but I mean, if it works, it works. So
Yeah.
did that do the job?
Already.
Anyone else?
I'm having issues just with ggplot2, but I'm going
Okay, okay. If James can, yeah. Okay, cool. So anyone else having issues loading in the data set? Cool. So yeah, this line of code over here will return a subsetted version of diamonds that just has the first 1,000 rows, so it'll plot a lot faster. Your plots won't look as, point dense as the ones I'll have up here, but the code you'll be writing is essentially the same. Bless you. So the basics of plotting with ggplot, and we'll start off with a scatter plot, old faithful. So I'm going to use a markdown header here, just one hash, and write plotting with ggplot2. For those who are new with this, the use of markdown headers is, well, not only does it kind of render nicer if you later end up exporting this file as a PDF, down here in this kind of status bar section, it'll create a little table of contents for you as you go along. So this is a really nice way to kind of delineate sections within your notebook as you go along. So plotting with ggplot2, and then we'll add 2 hashes here, and we'll write scatter plots. If you want to check the status bar again, notice it's nice and indented. So I would recommend kind of making a habit of using these because I love kind of organizing my code, and this really helps with that. So to start off with ggplot, kind of the bare minimum we need to do is just use its core function, which kind of unpredictably is called, very predictably is called ggplot. Not the 2, just ggplot. And the first argument or input that the ggplot function takes, much like the dplyr functions we encountered last time, is just the data frame you want to plot. So we'll write diamonds. So running this on its own gives us absolutely nothing, and that's fine. The reason for this is we've specified that this is the data set we want, but we haven't told ggplot anything else about, what, let's say, variables we want to plot. What do we want on the x-axis, the y-axis? Do we want axes? So far, ggplot's not going to return anything to us, and that's fine. So we've done the first step. The next is to specify what are known as the plot aesthetics. And this has always been, to me, a really fancy way to just say what goes on the axes. So to define the aesthetics, I'm going to write a comma after diamonds because this is going to be a second argument or input to the ggplot function. And we're going to use a helper function here. So this is a little function nestled within our ggplot function. That'll be AES, so short for aesthetics. And within aesthetics, we have to specify what we want on the x and y. So on the x-axis, let's say we want to plot the carat of our diamonds. Comma, on the y-axis, let's look at the price. So how does price vary by carat, essentially? All right, and once we run this, surely we're going to get a plot. We do not. You'll notice, though, that now there's these axes, and they seem to kind of, you can scroll up real quick if you'd like, they seem to correspond to the range of values we see up here on, let's say, the y-axis, which goes up to almost 20,000 or so, and same goes for carat. So ggplot is essentially primed what we wanted on the axes, but it's not quite going to jump ahead to plotting the actual data just yet. And this is where our first geom comes into play. So plotting or making various plots in ggplot revolves around this family of what are known as geoms, or I forget the exact origin of that term. I'm sure it's short for like geometric or geometry or something, but let's just roll with it for now. Now, this is going to be a bit new to some of you. I won't blame you for maybe raising an eyebrow at it, but at the end of the ggplot function, add a plus. Just a vanilla plus, no fancy operator fluff around it. And after that, hit enter. You'll notice there's a bit of an indent here because R is kind of anticipating that you're going to write a bit more that's linked to this function. And then we're going to write geom underscore point with an empty set of parentheses. No input arguments to geom point. Just make sure to have the plus on the previous line. And once we've done this, now we have too many points, but there we have it. Now, what we've essentially done is specified the data frame, specified what we want on our x and y, and told ggplot how to plot it, and it's very happy to do exactly that. So here we see that there's a huge cluster of points, but an overall, mostly I would say positive relationship between carat and price. So this is kind of the most basic ggplot syntax. This is how you can make any sort of plot. The later geoms we'll be looking at will also follow this basic structure. We'll just be adding and in some cases removing some of this basic structure as we go along. So any questions right now? Anything looking funny on your screens?
What's the significance of the geo point being on a separate line? Is that just so that it's
Right.
not split?
Yeah. It can be on the same line. But as we add more things, it's nice to have each of them on a separate line. It's just easier to look at.
So for the first line, you need to put the data frame and the x and y.
Mhm.
It's like for all of the graphs you want to make.
Yes.
It doesn't matter if it's box plot or.
Yes. So that's a really good question, and that kind of gets at something I wanted to mention. What we're doing essentially here in this initial ggplot call, you can think of as global settings in a way. So anything else we add below this, and in short order, we'll see how to add further. Well, not necessarily geoms. You won't often find yourself adding multiple geoms, but anything else that's added onto this ggplot chain will kind of be plotted with these aesthetics in mind and with this data frame in mind. Another question?
Cover what a geom point is and why it doesn't have an argument?
So geopoint is a function which on its own doesn't really do anything, but when it's tacked onto a ggplot call like we have up here, what geopoint does is it kind of inherits the arguments we've given to the ggplot function up top, and then just quietly plots them as a scatter plot. So the arguments of geopoint are actually just simply customization. So you could change the color and the size of the points, and that's something that we'll briefly touch on the customization side of things, but on its own, the only real arguments it needs are what's on the x and what's on the y, and it kind of gets us from the main function anyways. Cool. Now, the last thing I want to mention before, well, two things I want to mention. One is that you could actually save all of this to an object. So far we've just plotted it as is, but it hasn't been saved to anything, which means that we could take that same old assignment operator we've been using and save this entire plot as an object, which let's say we'll just call P for now. P assignment operator, just shove that behind the ggplot function. And then if you run this, the plot disappears. But what has happened is that the plot has been saved to this object P. So if I were to open a new code chunk and just write P and run that, it'll spit out the plot. And the cool thing about this is you can actually, you've got all these stored into P, you could actually continue adding things to P. So in fact, it's actually feasible, and you guys don't have to do this, I'm going to do it for the sake of demonstration, to remove geopoint from up here so that P is just the global settings. And then I could say P plus geopoint, and it's essentially equivalent. This is pretty nice because you can kind of take a bunch of these ggplot elements that you've chained together, save a chunk of them to an object, and then experiment with adding other things without retyping or recopy pasting the entire thing. In addition, it's important to know how to do this because when you save plots, they have to be within an object, as in save plots to like, or rather output plots, that's a better way to put it. Output plots to like a JPEG file or PDF file, they need to be in an object. So it's helpful to know this even if like you might not necessarily be doing it all the time. Any questions about that? All right. The actual final thing I want to mention before I go on to other geoms is that you have to make sure to have the plus at the end of a given line. If you have the plus down here, and then you try running this whole thing, ggplot doesn't like that. It won't interpret it correctly. The plus needs to be at the end of a line. And if you'd like, you can keep a note in here for yourself. The plus has to be at the end of a line. Exclamation point, because we're really excited about this. You'll notice even the error just directly says, can't do da-da-da, did you accidentally put plus on a new line? So it's really important to keep that in mind because it's a source of a lot of errors that you might not even notice in a larger chain of commands. Cool. So now I'm going to touch briefly on the arguments thing. So Rose kind of asked this, so I sort of spoiled it already. But within geopoint, we can proceed to feed it other arguments to kind of customize what we've got here. So a really useful one in scatter plots in particular, especially if you're in like genomics world or just deal with large data sets in general, I'm going to put this on a new line again, is the alpha parameter. Now, if you were, actually, let's just start with this. So alpha equals, and alpha will take a value between 0 and 1. And this value will determine the transparency of your points. So notice here we've got this giant opaque clump of points. And in these completely like darkened areas, God even knows what's happening. So what we can do is actually reduce the alpha value to say 0.5, which makes them about, halfway. Well, literally halfway. Rerunning this will make some of the points, or will make all of the points a bit more transparent. And it kind of shows, it's a bit easier to see which parts are actually really large clusters of points, as opposed to our previous plot. So the alpha value, you could bring it down to 0.2 if you'd like. You can experiment around with it. But I'm pointing this out because the name alpha isn't immediately suggestive of what it actually does, but it is such a useful argument that I often find myself using in all sorts of plots. All right. So, question?
Is there a reason why you putting in the alpha thing might not actually have changed the transparency at all?
No, it should change the transparency every time.
And the number just specifies the proportion of your data set that it's changing?
No, just you could think of it as like 1 being completely solid and 0 being invisible. and it just kind of scales
It
the
does not look different.
color to that. I mean, if you're trying to change the alpha value to like 0.1, do you see something different?
Down to 0.2 and it looks exactly the same.
Are you using the shortened version of the data set, the subsetted version?
Oh,
If you're using the n equals 1000 version of the data set, it's probably a lot less dense.
wait.
If you're using, I'll scroll back up. If you're using this version of the data set, it's going to be a lot less dense. So the alpha parameter might seem a little less obvious.
Hold up. Okay, let's just see.
Because it's 54,000 points versus 1,000.
Okay, that's my original sheet. And then,
You're doubling the whole points because you have GM point added to this object, and then you're adding another GM point.
Oh, yes. That would do it.
So you can use
So-
the original.
so this is right.
So in the meantime, another thing I'm going to do is, so far, in our aesthetics, I've just mentioned them as the axes. They're what's on the X and what's on the Y,
Got it.
right? Everyone good? Okay. So I'm going to open a new code chunk down here. So typically building plots with ggplot, I would say, is a bit of an iterative process. So we've seen a little bit of that already in that we first determined our aesthetics, we then decided on our geom, we then decided on an alpha value. And another thing we might go back and do to further kind of stratify what's going on in our data, I'm just going to write out the entire function again. So ggplot, feel free to copy it down. Diamonds, on the x-axis, we have caret. On the y, we have price. Whoops. Plus, yeah, I'm just typing this out again down here to leave everything up there intact. So we've got this giant clump of points, and we've looked at the relationship between caret and price, and that looks great. But perhaps there's something, like if we notice these giant clumps happening in our data, perhaps there's some other predictor that could explain why this clustering is happening. So if we're to scroll back up to our data set here, we've got a couple categorical variables such as cut, such as color, clarity, and so on. And it just very well may be the case that one of these is actually a strong predictor for why some of these clusters are forming. So kind of surface level way to look at that would actually be to set a new aesthetic called color. And I'm going to do that up here in the global settings. Color equals, and let's start with cut. Everything else essentially stays the same. And what happens here is that ggplot will inherently group the points by different values of cut and then color them accordingly. So now we get this a much more colorful plot. What we can do is change the alpha value again, so it's a bit more visible, or not visible, but maybe easier to digest. So there's a lot going on here. And while cut doesn't really seem to be that predictive of what's going on cluster-wise, let's take in a second to think about what has changed on the ggplot side of things. So over on the right-hand side, we now have a legend, which is pretty nice. And it's determined a color gradient for us automatically. You can change these manually. There's ways to do that. I don't think we'll be covering those today, but I'll be happy to talk about those later on. Where it automatically takes the different levels of the cut variable, assigns colors to them, and then shades in the points accordingly. So it will do this for pretty much any categorical variable we feed into color. And now that we see that cut isn't really the best predictor, let's say, maybe let's try clarity. So I'm just going to change cut to clarity. This to me seems a bit more, I don't know, informative. So did that render for everybody? The people with the subsetted data frame, do you see the same pattern roughly? With like kind of this. Because what I see here is, while I don't offhand know what these clarity measurements mean, so this IF metric of clarity, those, even at really low values of caret, seem to fetch really high prices. Whereas almost none of those IF, or none of the points over and higher values of caret are, none of the points over this side of the plot seem to be classified as IF.
So if our plot doesn't look exactly the same as yours, could that just be like the screen is a little different? Yeah.
Definitely,
Like
yeah.
alpha will render differently on monitors with different resolutions.
Yeah, that's true.
Just 'cause there's like a lot of space in the middle here, and there really isn't.
Yeah, ggplot is a little annoyingly dependent on the size of your monitor.
Right.
So if I were to actually unplug my laptop right now and replot this, the dimensions would be different because right now it's hooked up to that.
Okay. That makes me feel better.
Yeah,
But all of the data.
the data will still be there. It just tries to like intelligently fit to your screen. Cool. So that's scatter plots. Any questions on that? All right, now we've got the basic kind of anatomy of a ggplot called down. And what that means is we can kind of like bull rush ahead and check out all the other geomes. So the overall structure will be the same. We're going to mention the data frame, our various aesthetics, whether we want anything fancy happening, such as coloration. There's also fill is another aesthetic, and so on. So, and then what the actual geomes we want to plot might be. So if we're to explore line plots, so I'm going to go hash line plots. Looking back at our diamonds data set, so let's just bring that up again. Diamond.
I have a quick question.
Sure.
It's just that in Mac, I don't know, you have to put Control-Shift-I?
On Macs, it's Command-Alt-I or Command-Option-I.
Control-Option-I also works on Macs.
True. True. Right.
Okay, that's why.
I forgot.
Okay, cool. Thank you.
Yeah.
It's either.
It's, yeah, Control and Command. Such confusing keys. Anyways, so here's our diamonds data set. And something you might be curious about, given what we've seen up here, is let's say for each value of carat, what is the mean price that a diamond of that carat fetches? And of course, we could perhaps fit a line to this or some sort of model, but that's something we'll deal with later on. Let's say we just wanted like a really simple line plot, where for each value of carat, we just have the mean price for all diamonds in our data set with that carat value. So unfortunately, ggplot on its own, while it's really good at plotting, it's not super good at data transformations. But you know what is? Yeah. I didn't expect the room to shout that out per se, but come on. So what we're going to do real quick is delve back into dplyr. So make sure, again, you have imported dplyr. We did this at the start of the lesson, but if you happen to not run this, now is a good time. dplyr, for those who weren't here last time, I won't go super in depth about it, but the idea of dplyr is that you kind of chain a data frame through a series of operations using what's known as the pipe operator. And that's something that'll actually, I think, make more sense as we type it out and explain it. And what that allows us to do is kind of write out these complex data transformations step by step. And then at the very end of that, take the output of all those data transformations and just plot them right into a ggplot function. So if that did make a lot of sense, let's actually write it out in code, and hopefully that will help. So when we're writing a dplyr pipe chain, we're going to start with our data frame. So that's diamonds. And then what we really want to do here, if we're to look back at our data frame, is we want to group by values of price. So over here, we've got price. Let's say I want R to take all the values of carat that have a price of 326 and give me their mean. Do the same for those of 327 and so on. But I also don't want to write a million horrible for loops, so I'm going to use dplyr for that. And the way you do this in dplyr essentially is you would add in the pipe operator, which, so here's another funky shortcut. I promise it's the last I'm going to throw at you today. Control/Command, if you're on a Mac, Shift-M. M for Mac. And once you type that in front of diamonds, what you'll get is this funky looking thing. If this is very confusing to you and you've never seen this before, don't worry about it. But what you can think of this as doing, what you can conceptualize this as, is it's taking whatever's to the left of it, and whatever function I put to the right of it, it's going to feed it as input. But instead of putting it directly to the right, I'll just put on a new line for clarity. And the first function I'm going to pipe this into is called group_by. And the argument to group by will be price. Then I'm going to add another pipe and write summarize. In summarize, the arguments it takes are mean carat, which is going to be our new column, and then that operation is simply the mean of carat. If you have never seen the syntax before, don't freak out. You don't really need to understand it to figure out what's going on today, at least. But I would highly recommend going through the Intro to R material if you weren't here for the workshop that I emailed out again today morning, because it goes a lot more in depth into these functions and how you can use them for these transformations. So if we just run this as is, we're going to get a new data frame, which just has price and mean caret. And what's going on here is that for each value of price, dplyr has calculated the mean caret value. And you're right.
Yeah.
So what's nice about this is we can basically pipe this data frame. So just add a pipe right here, hit enter, and then start our ggplot function. Remember I said in the beginning that the first argument in ggplot is a data frame. Again, totally by design. It probably helps to know that the guy who made dplyr also made ggplot. So one would hope that his signature packages would kind of work together nicely. So since we're piping all this forward, we don't actually need to write diamonds here. Essentially, the kind of the data frame that the ggplot function is getting will be the output of all of this because of how the pipe works. Again, if that's a foreign concept, I would review that material. Once you just wrap your head around it, or once you've played around with it enough, you kind of just, it starts making a lot more intuitive sense. So all we really have to write here are the aesthetics. We're going to write AES, X equals price, and Y equals mean caret. Right? And I'm going to type in plus, careful not to do the pipe again, just plus geom underscore line. And here we're introduced to our second geom of the day. So what this is going to do is put these price values on the X, these mean caret values on the Y. And once we've done that, we can run this entire pipe chain. So you could put your cursor anywhere within this block of code and press Control Enter. And we get this incredibly oscillatory line plot. But essentially, we've gotten what we wanted. We've got price on the x-axis, and then each of these is a single point, or a line drawn through a series of single points, showing us how mean caret varies over price. So there is a net kind of tendency to increase, for caret to increase as price does, which is what we'd expect. But in a way, this is another useful way to kind of look at this absolute mess of points we've got up here. Any questions about that? Cool. So again, if you're not super familiar with dplyr, the takeaway is this. Thing on the X, thing on the Y, geom line. Same syntax as what we had earlier with the scatter plot.
Is that one used for like time series? Like
Yes, it's great for time series.
Okay.
So you would put those on the X, your, whatever your dependent variable is on the Y, and it would just format that nicely for
I
you.
wonder if in this case it would actually make more sense to group by caret than price.
Yeah, actually,
Right, because
that'd be fun to do.
yeah.
Let's do that real quick. Change caret. Price. Basically replace both instances of the words with one another. Whoa, wonky. I mean, same trend, but yeah, this actually is a little more easy to parse out by eye.
Yeah.
But the relationship still holds. Math is not a lie.
But this is a lot for like more convincing.
True.
Yeah.
See, making plots is an iterative process. I'll leave this up here for a sec, just in case people are still copying this down. And I will update the lesson on the internet. But this here highlights a really important thing I want to mention, is that this is an incredibly common operation to do a bunch of stuff with dplyr to munge your data frame however you want. And at the end of all that, just pipe it into ggplot and plot it as is. It's an extremely common operation, and one that I do all the time, as do many other R users. Cool. So now we're going to cover histograms in our quest to go through the gallery of geoms. So histograms, I mean, like the plots themselves, are pretty straightforward to code up in ggplot. What's nice about them is, so let's say here we just want to see the distribution of caret. One would write ggplot diamonds, and the aesthetic helper function again. What's important to know here is there's only one aesthetic, and that is the X. So in this case, that would be caret. And the reason for that is by definition, the y-axis of a histogram is count, right? We're binning our data. So there's no need to specify that Y aesthetic. It's on, like ggplot is smart enough to know that if you're plotting a histogram, that you don't need a Y aesthetic. So we'll add our plus here. On a new line, we'll add in geom histogram. Empty pair of parentheses again. And it automatically kind of, well, I think it sticks with, 30 bins by default, but it'll bin your data and then automatically set the y-axis as count. So naturally, most of the time you won't be wanting 30 bins, or you'll be wanting more specific intervals. So geom histogram takes in two, two arguments, not at the same time, rather. I think they're mutually exclusive. You can't run them both at the same time. What you can do is either specify bins or bin width, one or the other. So bins will specify a fixed number of bins. So let's say you just wanted 50 bins, and then ggplot would subdivide the histogram into that many for you. So I'll just do that here. Bins equals 50. And we get a bit more of a stratified plot here. You'll notice like the bars are a little thinner. However, what I've found in my experience is the much more common way to go is writing bin width and specifying that. So let's say a bins of 0.05. And then what ggplot will do is split caret into bins of 0.05, intervals of that much, and then do that binning accordingly. So what a histogram does is, let's go back to our data frame. So we've got these values of caret, but we have no idea how they're distributed. And this could be of interest to us if, let's say, we want to check for normality just by the eye test, for one. So what this will do, or what histograms in general will do, is take out these values of caret, basically make a little number line out of them, and assign bins. So let's say bins of 0 to 0.1, 0.1 to 0.2. And then if like 50 observations fall within the first bin, it'll plot a bar that's
So the bin width here is
how fine your intervals are,
Yeah.
let's say.
Okay.
So it's relative to the X that you specify.
So caret, you'll notice, goes from 0 to 5 in our data set. If I set the bin width to 1, it's going to look chunky. It's a chunky boy. All right,
I
and
have a question.
sure.
If you put like ggplot and geom histogram bin width, and you save that object like in
Yeah.
P, for example, and then you want, instead of putting bin width, like only bin, and you put plus geom histogram bin, and it's going to replace the.
That's a good question. It's not. It's actually going to plot it on top of it. So this is something we'll see when we get to bar plots. But if you add a second geom, even if it's the same geom, it just plots it on top. So it'll be essentially equivalent to us typing in geom histogram again. I think it might actually break because the x-axis might be a little different, but let's just try it.
Or maybe bin width 0.0.
Right, okay.
Not just to know if it replaces the.
Yeah, it'll get a little bit messy because you can't really see it over here. I wonder if I could change the alpha value. I've never used alpha values on histograms. Yeah, so it just plots it on top.
It doesn't replace the other one.
We are going to be doing that more later on. I don't want to introduce too many ggplot concepts while introducing geoms at the same time. I'm glad though. No, it's good. It's good.
This is really useful though. I've used this to plot like overlapping histograms, because if you set the alpha to both of them,
Yikes.
the overlap becomes a different color because it becomes the merging of the two colors. So you can have like one blue, one red, both at alpha 0.5, and the overlap becomes purple. And so like you can just clearly see it.
I've just used position equals dodge for that, and then just next to each other. But I guess that works too. Yeah, we were going to get into stacking geoms later on. I didn't want to introduce too much ggplot and too much data viz at the same time, but I'm happy to have this spoiled. So yeah, any other geom, it just plops it on top of it. And this is important because sometimes you want certain elements on top of others. You can imagine if you've got a scatter plot and a line fit, you don't want the line to be hidden underneath the points. You want it to be on top of those. So the order which you place geoms, ggplot is like ogres and onions. It's made of layers. That's the worst joke I've got for you today. But then no food for you. You have to tolerate my horrible jokes if you want food. All right, so any questions on histograms? So now we're going to touch on bar plots real quick. Now, the bar plot section is a bit more involved, and I'm realizing we're already approaching 6 o'clock. So let's do box plots first real quick, because those are also relatively straightforward. Does everyone know what box plots are? I realize I shouldn't be making assumptions about what people are familiar with. Okay.
Just have no stats knowledge, don't mind.
Neither do I. I dislike plotting. So box plots. Now, box plots are useful for visualizing the distribution of a given set of points for a certain categorical variable. So that's not the best explanation, but in a ggplot sense. So in order to make a box plot, let's say we wanted to see, I mean, earlier when we were making our scatter plot and we colored by clarity, we saw like what seemed to be like these really clear clusters. So what we could try to do is visualize the distribution of price, which was on the y-axis of our scatter plot, if you remember, across the different values of clarity. So box plot would be really good for that. So we start as we have before. Hopefully this is starting to become a bit like muscle memory by this point. ggplot diamonds, comma, an X and a Y, because on the X we have clarity, but on the Y we have price. And then we hit a plus as we did before. The only difference here relative to, let's say, geom point or whatever else is we just type in geom box plot. All right. Once we've done this, we get, whoa. I think I actually had caret in my notes. Nope, I've had caret on the X. Silly me. Nope. Clarity, caret. You're right. Yeah, I had caret on the Y in my notes, and I was just reading the wrong ones. Nice. All right. Yes. So the I1, which we noticed earlier, was on the right side of the plot, was like shaded dark purple, is kind of all over the spectrum here, although it's largely concentrated because remember, box plots show the median over here. Whereas the IF, which was all the way on the left-hand side of our plot, which had low caret values but price values all across the range, is pretty much concentrated just there. So this is pretty much analogous to what we expect given the clustering we saw over there. But from the ggplot side of things, what I want to emphasize is this is essentially the same as before. And this kind of really highlights the sort of, I like to think of as the modular nature of ggplot. You have the same kind of starting point, and then you just kind of tack on whatever geom you'd like. And it's very responsive to that. And this goes even further back to this idea of high-level plotting. We said, put this on the X, put this on the Y, make a box plot. And that was kind of the extent of our computer jargon. So that's something I really like about ggplot. And I would say a reason why we're teaching this over base plot, because there's always someone who really likes base plot, and they're welcome to do that. But I'm a ggplot fan. Anyways, so the final things we're going to touch on my side of things are bar plots, and then we're going to talk about line fits. So bar plots are a little more involved, which might strike you as ironic because bar plots themselves seem like relatively uncomplicated to interpret. But in our example, let's say we want to plot, so what we've got up here, clarity versus caret, let's say we just want to create a bar plot of mean caret for each of these values of clarity. So for something like that, we actually have to go back to our trusty friend dplyr, because it's, at least it's the way the diamonds data set is structured, we can't quite immediately do that. So what we would do is start with diamond once again, and then do a bit of piping. So in this case, since we want mean caret for each clarity value, I mean, mean, yeah, I said it right. It's been a long day, guys. We group by clarity this time, and pipe to summarize. This is another group summarize operation. I'm going to create a few variables here, so I'm actually just going to hit enter again, just so they're all on separate lines. And the first I'm going to create is mean caret equals the mean of caret, similar to what we did before. Standard deviation of caret. And here we use the SD function, which is also available to us in R itself. You don't need to import a package for that, I believe. And the final one, this one's going to look a little funky. N equals N in parentheses.
It's 6 o'clock.
Thanks, Mac. Huh? Yes, I'm gonna calculate standard error with this because there's no straight function for it.
Oh, you're gonna.
Yes. You have to like import a separate function, a separate package to calculate standard error, which is a bit
You
annoying.
can do it in Summarize, so using the variable.
Can you?
I think so. It'll just have to call. Do it however you were gonna do it.
I'll just stick to mutate. Don't want to debug issues with that. So what we're going to do is calculate standard error here. And once we've created these new summarized columns, let's actually just peek at them. We've got different levels of clarity, the various mean caret values. So these will be the heights of our bars, standard deviation, and the number of observations we have for each of these levels of clarity. And we can use all of these to calculate the standard error. The formula for this I had to look up, even though James told me, because second year was a long time ago. So SE caret equals SD caret divided by the square root of how many observations we had. So this is a mutate observation. If you've never seen this before, what it allows you to do is column-wise operations. It's one of my favorite functions, well worth kind of getting familiar with if you plan to do more data wrangling in R. But again, not super important right now. What matters is if you run all of this, you will get this host of useful values, and we can use this to create our bar plot. So this is a lot of typing, so I'm going to stop for a second so you guys can copy it down. Cool.
Quickly, can you explain again what the n equals n?
So yeah, so the n parentheses function, this is actually, I believe, a dplyr specific function. Correct me if I'm wrong. But what it does is it works specifically within summarize, and it'll just count the number of observations.
Oh.
So if I didn't have a group by, it would just return how many rows there were. But since I have a group by preceding it, what it does is for each level of clarity, for let's say I1, it's telling me there's 741 rows with clarity I1, 9,000 rows with clarity SI2, and so on.
Keep in mind, and this is relevant for probably everybody here because of the kind of data that we use, it's counting the number of rows, but if you're calculating standard errors and stuff, you don't want to count rows that are NAs. You don't want to include missing data in any of these calculations, right? So if you wanted to count the number of rows that only have data values, for example, you'd have to use a different system. And like you'd want to remove NAs when calculating the mean and stuff. And there are easy ways to do that in dplyr, but just like remember that if you have missing data, you have to do this a bit differently.
Right.
But the basic syntax is all the same.
Mm-hmm. So the filter function, for those who were here last time, would be your best bet to do that. Shameless plug, James and I, with some other people downtown, taught a course called EB313 last semester that basically teaches stats and such with an ecology focus in dplyr and ggplot, and we pretty extensively cover how to deal and work around NAs in that. So if you look up this lesson online, links to all of that lesson material can be found, and it's all available online if you wanted to see how to like best deal with NAs in your own data when doing something like this. Anyhow, so now that we've got this data set, we can actually do what we came for, which is plot it. So let's add one final pipe and then type in ggplot. Again, since we're piping into ggplot, we don't need the data frame here. We just go right into the aesthetics. And this time on the x-axis, we are going to want clarity. And on the y-axis, we have mean caret, the heights of our bars. Plus, so after plot, just hit enter again, geom bar. Now, geom bar is a bit of a finicky geom. And the reason I say that is remember when with geom histogram when we didn't specify a y aesthetic and ggplot was like, I know what you're trying to do, and just like did the counts for us. Geom bar by default tries to do some sort of similar transformation. I believe it does counts as well. I think I've just kind of overridden it every time. Basically, I find it a bit unpredictable and annoying, which is why I always do this sort of thing explicitly. And then you have to specify this argument stat equals identity in quotes. And what that does is tells geom bar literally plot the values on the y. So in this case, mean caret. Like these values here, these are the heights of the bars. Don't do any kind of funky transformation, just plot them as is. Because otherwise it starts raising these wonky errors. I'm sure if you got familiar with that, it'd be a bit faster, but I like doing it this way because it's more explicit. So once we do this, we're going to get a nice bar plot with clarity on the x and mean caret on the y. Did everybody get that? Cool. So while we're doing blah, blah, blah. bar plots, we calculate all the standard error stuff, right? And the reason I did that is to introduce this idea of stacking geoms, which we've introduced already, but I'm sticking to my script. And actually introduce a side geom here called geom error bar. You could plot error bars on top of your bar plots using the standard errors we just computed up there, which is obviously something you'd be wanting to do if you're plotting bar plots. So the way error bar works is it actually does require arguments. It's not automatically going to infer what's going on. It requires aesthetics. So you do need that aesthetic function. And within AES, you have to specify a min and a max. So the idea of like the bottom of the error bar and the top of the error bar, like what values those have. But we only have one standard error column, right? Fortunately, ggplot actually allows us to do a bit of math right here. So what we can do is write y min equals mean caret minus SE. Right? Then right at the end of that, type in a comma, hit enter, just for clarity, and then y max equals mean caret plus SE. What this is going to do is that for each level of clarity, it's going to take the mean caret value, subtract SE and make that the lower bound of the error bar, and then calculate the upper bound of the error bar with this operation here.
Can you change the fill of the bars to white? Because otherwise we might not see the bottom.
Yeah, true. Is it? Oh, yeah. It's,
You specify an SE above or like just?
oh, sorry. This should say SE caret. My bad. Not SE. So up in this mutate column, mutate function, we created this column called SE caret. Sorry, not just SE. Thank you for catching that. Another thing, I also added this thing in geom bar. I added fill equals white. This is going to make the bars colored white, and it'll make the error bars a bit easier to see. So just after stat equals identity, add fill equals white in quotes. So once we run all this, those are tiny little error bars. But here we have it. So we've got a bar plot, we've got our error bars, and we did it all in dplyr and ggplot. So I'll give everybody a second to catch up here. Anyone have issues with that?
I have a question.
Sure.
If you wanted to extend the y-axis to make the error bars more visible, what's how you do that?
Like extend, like stretch out.
Yeah, just stretch it out so you can the error bars like on the right don't look like a line.
Right. So I believe changing the dimensions of a plot in here, I don't think you can really do that. You can alter the scale of the plot and like zoom in to like, let's just say this part of the plot. But to actually stretch out the plot, that would have to come at the point when you're actually outputting these plots as files. Because then you can determine the dimensions and stretch it out.
You could use theme to change the aspect ratio, but I don't know what influence that would have on your ability to actually see the sticker.
Yeah, I've never done that.
You could also just plot confidence intervals, which wouldn't be as small.
Or standard deviation.
Yeah.
Or standard, which is what I did at first, but it was like.
I find that to be less common. But like when you have this many observations, like your standard errors are almost always just going to be like little teeny things.
Right.
I'm like, we're ecologists, we're never gonna have standard. Yeah.
That's true.
Yeah. While I'm here, I'm going to plug an additional function, which actually isn't in the notes, but I think is worth mentioning. If you do want to zoom in on a certain part of the plot, there's a really useful function called coord Cartesian.
I have a quick question.
Sure.
When you put the error bar, does it adjust like the y-axis? Like, for example, if it's a big error bar?
Yes, it will. The error bar will be like flying off the plot.
It's going to adjust it.
It will. It automatically determines dimensions based on whatever's in the plot. You can use coord Cartesian. I almost said Kardashian. To like kind of zoom in on a certain aspect of the plot, zoom out if you want. The important thing about it is it doesn't actually change any of the data that's plotted. Essentially, I believe what ggplot does is still plot everything as is, but then focus on the subset you've determined. So if we wanted to just, so like Celia said, maybe make the error bars a bit more visible, I wouldn't actually plot a bar plot like this, but just for demonstrative purposes. Let's say I just wanted to see from y value 0.4 to 1.5, you could type in y equals c, so that's our concatenate operator from way back when. 1.5, or sorry, 0.4, comma 1.5. And what this will do is set the y-axis that even though everything is plotted, it just shows values 0.4 all the way to 1.5. So this is a useful way. You could analogously set the x parameters, although I don't think the x parameter makes much sense in a bar plot because it's not continuous. But for continuous data in particular, you can use chord Cartesian, to kind of alter the scale of things, but not actually change around the data. And the reason I mention that is because if you look at the ggplot docs, they will recommend you use a series of functions called scale x continuous and scale y continuous. And although these are really powerful and useful functions, they will actually alter what's plotted. So if something is out of bounds for them, ggplot will not plot those points. Bit of a side tangent. Don't worry too much about it, but chord Cartesian is a very useful function. So the final thing I'm going to go into is fitting lines briefly before I will hand it over to James, even though I've eaten through most of his time. So the last thing we're going to do is model fits. So let's go back to our original scatter plot. Let's just type it out again. ggplot diamonds, aesthetics, x is caret, y is price, not pricey, price, plus geom underscore point. Now, very commonly when you are displaying scatter plots in your papers or presentations or whatever, you also have likely done some sort of stats to see whether your relationship is statistically significant. You've maybe fit whatever sorts of models to your data. And visualizing that is probably high on the priority list. So ggplot, fortunately, actually kind of consolidates all sorts of fits into one single geom called geom smooth. So we'll add plus and then geom smooth underneath this. And it's important to have smooth as a second one, because otherwise the line will actually be plotted underneath the points. Because essentially smooth, the line will be plotted first and then the point will be plotted second. So make sure to have point before smooth. Remember, layers. I won't make that horrible joke again. But you're all thinking it, aren't you? Now, if you run this, it'll take a second because it's actually doing the fit in the background. And suddenly, we've got a fancy fit going on. Now, geom smooth will automatically try to determine what it thinks is the best model for your data. So it could be quadratic, it could be a low S function, GLM, all sorts of things. But I've found in my experience, like it's trying really hard, but really does it give me what I want? If you want to specify a certain model, you would have to use the method argument. So method equals, so a really common one would be the linear fit. So in order to do that, you would type in method equals LM in quotes. And this forces geom smooth to plot a linear fit to your data. Nifty, huh? I also have to mention, it's less visible here, it's maybe more visible with the original smooth. There are like these little gray bars around the line. What was that again? Was that standard error? Was that? Yeah. By default, it plots standard error as like gray bars on the side. You can turn that off with a separate argument, which it can be found in the documentation.
So it makes a linear regression on the aesthetics you have.
Yes, exactly.
Can you change the color of the line?
You can. So that just goes in as a separate argument. So color equals red, let's say. Which is a bit.
Is that when you don't specify the method, it just chooses whichever fits the best?
What it thinks fits best. Which in my experience, like again, it's trying really hard, but it's rarely on the money.
Could you then there, instead of like getting it to just calculate the relationship, like put in then the name of an actual like model that you've run, like maybe like okay, so like you run a regression,
yeah,
and I don't know, you have something specific. Can you then instead of LM plot that regression line on that data?
Like an outline.
Yeah.
Yeah, like
I did that once in a super hacky way, where you can use the predict function on a linear fit to basically create a data frame with a set amount of values predicted by that model, and then plot that using geom line.
There's a slightly easier way. I mean, if it's just a simple linear regression, this line is going to be exactly the same as the line in the model.
Right.
If it's more complicated, geom smooth has a formula argument.
Oh
and
yeah.
you could specify
I forgot about
the
that.
parameters from your model object, and it'll just plot whatever line that formula generates.
Okay.
That's
so
way
that's how
easier
you
than
would
my
draw
method.
like quadratic or cubic lines and like more complicated things.
It's a super versatile function. Its documentation is huge. I keep mentioning documentation.
What's the function called?
Geom smooth.
And then the argument is formula.
If you ever want to look up the documentation for anything, reminder that in the console, just type in geom, or sorry, question mark, geom underscore smooth. Hit enter, and all the documentation is there. So here with geom smooth, trying to find formula, there. By default, it's just y on x. But you can modify all of this.
Yeah, you can modify it.
Turn off the standard error.
This amount times x plus whatever your intercept is, and like it'll just draw that line.
Yeah. Another cool thing is geom smooth is actually quite responsive to your global aesthetics. So remember early on when I'm going to remove the LM fit for a second here, switch back to its automatic fit, which either way. What I'm going to do is add that color aesthetic back in. Remember the one that showed that, clarity is clearly, having some influence. So let's add clarity back in here. Keeping geom smooth as is. Remove the method equals LM. If we run this, it'll take a second, but it's actually responsive to the global settings, and it'll fit a line to each individual group. So if you've got multiple groups in your data and you've run separate regressions for each, plotting them is super simple because essentially once you've defined that grouping variable in your initial aesthetics, geom smooth is super responsive to that. So, and even colors in the lines, and it's just like super nifty to look at. However, you may still want to color in your points, but still want an overall fit. I don't know, like people want different things. If that's the case, what you actually have to do is within geom point, specify aesthetics color equals clarity and remove it from the global settings. That's kind of the final point I'm going to leave with you guys. You could actually specify geom specific aesthetics. What this will do is still color in the points, but the fit will be for the entire data set. So think about what happened here. We moved the color aesthetic just to geom point, which means it's not in the global settings. So when it's geom smooth's turn to be plotted and it's looking at the global settings, it's like, all right, I've got an X, I've got a Y, that's it. That's all I'm concerned about. Whereas when we had color up there, it was also taking into account color when determining how to do what it's supposed to do. So you can be very flexible with these aesthetics. Any geom can actually take in an aesthetics argument if you want to be really specific about the kind of plot you're making. Cool. So with that, I'm going to hand it off to James, who has 15 minutes to teach you guys how to customize your plot.
There's that much more.
There isn't that much more, but I don't think we'll have time for the whole call out what you want section.
Oh yeah, that's
Okay,
always.
we have that.
Yeah, that's not that
much. Cool. All right, take it away.
Are you live streaming?
It's live streaming, yeah.
Dope.
You don't want it to be?
I don't care.
Okay.
It should. Yeah. Sweet. All right. Your key bindings are the same?
Save for control on caps lock, yes, which you will not be using.
I won't be using. Cool. That wasn't the same.
Command Option I.
Command Option I. It's the same. Okay. Sweet. So let's start. So we're going to go through sort of customizing the appearance of the plot. Yeah, I will. And then something called faceting, which I know some people in the department are going to be pretty stoked about because it's asked quite often. So customizing plot appearance. Did I spell that right?
Yeah.
So the cool thing about ggplot is that you have basically complete control over how everything looks. And you could customize basically everything about it in really complicated ways. I'm not going to show all of the complicated things that you could do, but I'll introduce sort of just some of the cool aesthetic changes that you can make. So all we're going to do is we're going to start by creating sort of a bare bones plot, kind of like Ahmed showed you earlier. Turn your caps lock on.
Control again.
Yeah. I'm not used to the alternative mapping. So diamonds, and then again, we have to specify our aesthetics. So AES, and we're going to create a plot with caret on the x-axis and then price on the y. So y equals price. Yeah. So it's possible that you already have this plot actually because you created it earlier, but you might not have it color coded by clarity necessarily. If it is, then you don't have to do what I'm doing here, but otherwise, otherwise you might. And then point Ellis. So this is very similar to the plot from earlier. Caret on the x, price on the y, points colored by clarity, and then we're just plotting this using GM point with some alpha value just so that we could see sort of overlapping points. And I'm going to run this to make sure that, well, to make sure that it works. And so there it is. So what we're going to do now is kind of customize how all of this looks. Like maybe you don't want this weird gray grid behind your plot because it's kind of ugly. Maybe you want like actual axes because now those axes don't exist, right? They're kind of just blank. So all of that can be customized. And that's sort of what we're going to work on doing just over the next few lines. So because we have, because we assign this plot to an object, remember now we could just modify that object by just adding layers to it, right? So we have this object P. So if we want to customize object P in a ggplot way, we just like add the layers to it successively, and then it just modifies that object. So the way that this works in ggplot is we use a function called theme. And so theme is what tells the plot how to look. And so you could actually create a really complicated theme, save that as an object, and then literally apply it to every single plot that you create. So all of the figures in a manuscript, for example, have a standardized appearance. And so we'll walk through like some of the options that you might apply to theme to make your plot look however you want it to look. I'm just going to scroll down a bit so that that's at the top. So the first is axis. So you notice how the minute I type axis in the theme function, you have all of these options, right? Like axis line X, line Y, text bottom, top, like all of these are things that can be customized. And this is only axis related stuff. It has like, we haven't even touched like backgrounds and like all of this other crazy stuff. So everything is customizable. So what we're going to customize first is just the axis title. And the way that basically I would say like 80 to 90% of the customization using the theme function, they all work off of like 3 basic element types, which if for axis titles is element dot, and you can see them here actually. So element blank, like if you set axis title to element blank, your axis title isn't going to show up, right? You're telling it like, don't write the axis title. But element line is going to govern things like the actual axes themselves, anything in the plot that appears as a line element. And then rect, we're not going to get into because you won't use it very often. And then text, which governs the customization of anything in the plot that deals with text. So the labels, and then the axis tick marks and stuff like that. All of that is customized using element line or element text. Sorry.
What is grub?
I don't know what grub is. But we could figure it out. We could just type question mark element underscore grub and it'll tell us.
The term grub is generally used in ggplot for actually joining multiple plots together.
Oh, so maybe that's it.
Maybe something to do with that. But
maybe if you have a faceted plot and you want to change,
I
like,
think so.
yeah, okay. So I don't know, we could play around with it. But because we're modifying a text element, the axis text, we pass element text. And then you just tell it how you want it to look. And so element text has a bunch of different arguments that you could give it. Family is the font. So maybe we want it to be Helvetica. Helvetica is actually the ggplot default font. But maybe you want like Comic Sans MS or something. You could put that in there. And then maybe we want to change the size, right? Maybe we want our axis labels to be size 14. You could also specify like bold, italic, like all of this kind of stuff. All of that can be customized. And then each element that you want to modify, you just separate them with commas in your theme call, right? So this is, I'm going to see if I could try and make it a little more obvious. But the point is that all of the elements that you want to change, you could just keep stringing them together, right? And so everything that you want to customize inside of your theme call, one after another. So maybe we also want to customize the axis text. So this would be like the label values along the axis ticks, for example. And keep in mind, like you could specify different aesthetics for the x-axis and the y-axis separately if maybe you want them to look a little bit different. And it's kind of the same way where we pass element text because it's a text element that's being modified. And then just the parameters, that's completely wrong. Yes. Size, and then color. And you have access to the full range of colors. I also want to specify, by the way, you don't have to name the colors. You could use hex codes and stuff like that. Like if you have a color you really want to use and you know it's hex code, you could just put that in here. And there are other like fancy things that you could do. So if we do this, this is the plot from earlier, and this is the one that we just generated. The only real difference between them right now and what I want to point out is just the things that we've changed, right? We've changed how big price and caret are and how big all of these labels are. So we've just customized basically the size of things. You could also, for example, if you wanted to, for the title, I'm just going to put it in here, face equals bold. Closing colon. Thanks. No. And so you could like bold your axes labels, which is nice if you want to just emphasize them. I'm going to go ahead and just keep adding stuff that we could customize.
So axis.title is for?
It's for this, like price and caret. And then axis.text is this, the labels.
Okay.
Does that make sense? Yeah.
So if you were to want to put a capital letter on price or caret and clarity, would you have to do that from the original data frame?
No, we could add it right here because we have. So there's a few ways to do it. You could just change the name of the column in the original data frame. That's kind of like a hacky. You can do that, but it's a bit more work because often you don't. If you have a longer axis label, you don't necessarily want to create this column in your data frame that has that really long label. Yeah. So it's actually easier to change the axis label in the plot call directly to whatever you want it to be. So just because you asked, you could do it using ylab. Let's say you wanted it to be capital price. And then there's a similar xlab where you could specify the x-axis label.
Not in the axis title bit?
No, because this isn't modifying the appearance of any of these elements. This is modifying sort of the actual data itself, and so it has to go in the plot call.
Like content versus appearance.
Yeah.
Okay.
So similarly, we can modify axis lines. Now here, the difference is that we're not going to be we're not calling element text because the axis lines are not text elements, they're line elements. So we need to modify them using the element line function. And similarly, it has aesthetics that can be passed to it. So black for the color, And then you could also set the size. And you could just like play around with different sizes that you like. And if we rerun that, you'll see now we have actual axes that show up. Whereas previously that was just blank because the default is white. Or maybe, no, the default's probably none.
I think it's not.
It's probably none. And then one that I'm a really big fan of, panel.background. Now, in this case, you don't, you could modify like the color of the background, for example, or how it actually looks. But personally, I think having the background there at all is kind of detracting from the data and just doesn't look very good. So you could actually just say, I don't want it there, and just set it to blank, and then it just won't show up. And so that would look like that. Does that make sense? I'll go back up to the code so that you guys could see it. So remember, all of this is still happening within our call to theme, right? And we're just modifying each of the elements of our plot one after another in the call to theme, changing them however we'd like to. And then finally, another incredibly useful one, I'm glad you added it, Ahmed, is you also have complete control over how your legend looks. By ggplot's default legends, the position always it's not always chosen in the best way. The size is not always ideal. So you also have complete control over that. But you could also just say that you don't want a legend because maybe you want to create it yourself. You could erase the whole legend, or in this case, what it did was just remove basically that weird gray background surrounding the points. But you could actually set the whole legend element to null, for example, if you wanted to erase it. You could also tell it like, I want the legend on top with the elements like horizontally across the top of the plot. All of that can be modified in theme. Yeah.
I don't know if we have time to get into this, but similar to Rose's question, I am like cannot figure out, is there a way to change the friggin' labels in the legend? Ugh.
Yeah. Yeah.
Like you want to change their
Rather than-
values or their order?
No, like I don't want S12. I want to put, I don't know.
So there's a few ways to do it. The first is to change the names of the factor levels in your data frame,
Right.
which can be done using dplyr and mutate.
Okay.
The second way, you could do it directly in your plot call like this using, I'm not going to be able to write it out from memory. It's like,
I mean, I can even just.
yeah, I have code for it. I could show it. I could show it to you, but you modify a legend element in a very similar way, and then you manually set the values.
Right.
And then it'll change what these are called for that particular plot element. It won't change them for all of them because you haven't modified their names in the original data set. But you can do it on a plot by plot basis.
It's within scale color mate. You have to create like a name vector where you're like, I
Right.
one is equal to what you want it to be called.
Yeah. So basically, like, because the aesthetic here, because we specified a color aesthetic, you have to use scale color manual and then manually set the values.
Right.
Does that make sense?
It makes sense.
I'll show it to you
Yeah, okay.
later. But the point is, like, whatever you want to customize about ggplot, you can. The only exception is adding a second y-axis. You can't. That's not allowed. People have asked, and they're just like, no, never. So the last thing we're going to cover is faceting. Faceting sounds super complicated, but it's really not. It's super cool. Alice was introduced to faceting last week, I think, and it's pretty exciting. At least I get excited about it. So everything is exactly the same. I'm kind of going to write out the code just to show you guys what it looks like. I'll explain what it does, and then I'll show you the plot. Like, faceting is easier to understand if you see it. So AES. So we're again going to have caret on the X, and then price on the Y, and we're still going to color code it by clarity. I should mention real quick, actually, going back to the themes real quick, ggplot actually has built-in themes that you can call just by using them. So you could actually just like look up ggplot themes, and there's a bunch of predefined ones. But you could also add additional arguments to this to like sort of use this as the backbone theme, but then maybe customize it further to your likings. The way that I do it, honestly, is I just sat down one day and wrote out like, you know, a 20-line theme that I really liked, created an object with it that was like my theme, and then you could just do P plus my theme, and then it just applies it to that plot, and then all of your plots look the same. And you could change it for like posters or papers or like whatever the function is. Anyways, back to faceting. So we're going to do the same thing as earlier. We're going to add points to this figure with some alpha value just so that we could see the overlap. So faceting basically allows you to create separate plot objects by some categorical factor in your data. So maybe you don't want all of the clarity values plotted on the same figure, but maybe you want different subplots for each of the clarity values. That's what faceting essentially allows you to do. This way you don't have to like create a, like subset your data, create a plot for each of them, and then like manually wrangle them in PowerPoint or Inkscape or something. You could actually just generate the plot, sort of generate the paneled plot in ggplot. And the syntax is a little bit weird, but basically you have to add a tilde and then the name of the column that you want to wrap.
Tilde is like by. Correct is by X.
Yeah. And then I'm just going to add a theme. I'm not going to write my own in this case, but it'll take a minute. But this is more or less what that plot would look like. And you could customize stuff about this as well. Like I'm pretty sure you could customize the spacing between these plots, like the size of the headers. All of that is customizable. But the main idea here is that it's creating a separate subplot for each of the values of clarity. And importantly, it's cool to realize that like it's mindful of the global aesthetics that you set, right? So if you set a separate color for each clarity, it's going to maintain that color in each of the subplots, which is pretty cool, so that you still have color separation of the different clarity values, but you also have physical like plot separation of the different clarity
So
values.
if you don't put color at the beginning, it is going to plot like all of the points in black. I would think.
Exactly.
But still, it's going to be.
Yeah. So you would still have separate plots for each clarity value, but each plot would just have black points because black is the default for ggplot. And then I'm just going to kind of copy and paste the first bit of code, which you shouldn't have to do because you could just assign it to an object, but I'm going to copy paste it anyways. And just show you guys finally facet grid. So facet wrap allows you to wrap around a single categorical variable that's in your data set, but you might want to create a grid of like multiple categorical variables and like plots for each of those. And so you could do that using facet grid. And I'm just going to generate the plot and then we could talk about it. And it's a second, but. All right, so this is basically what it's done, right? So instead of feeding only a single categorical variable on the right side of the tilde, we add a second one before the tilde, the other thing that we want to wrap around. And then now what it's doing is it's creating a separate plot for every combination of clarity and cut. And so like you could, it's really useful for like looking at patterns in your data, even like before you go to analysis, just like sheer data exploration and just seeing how things look. But maybe you find that like maybe you run a model and both of these things come out as important and you want to visualize them independently, you could do it in this way. And there are other ways to visualize that as well. There's a wrapping up section in the notes. I'm not going to go through it. It's basically just a list of the things that we went through. So the different geomes, faceting, like custom themes, all of that sort of stuff. But that's sort of the core ggplot stuff. The syntax for everything, no matter what kind of plot you would want to create, is basically going to be the same. Just remember that whatever you want to do in ggplot, you can do in ggplot, except the second axis. But yeah, so, you know, the world is your oyster when it comes to plotting in ggplot. And I think that's it. Do you have anything else?
I just want to say online, there's so much about ggplot that is kind of mind-boggling as far as reference material, tutorials, books, online books. So not only is anything possible, anything is look-upable. That's a word now, guys. I said it. The other thing I want to say is food is pretty much here. So thank you guys for coming. Thank you to Bugs for helping us make this happen and for providing the food. And yeah, if there's any other questions, we're going to be around eating food as well and are happy to talk ggplot and whatever else. So yeah, thanks guys.